Now, I wanted to talk about contactors. Before I did a video on contactors, and we went over some of the components of a contactor and basically how it works and all those things. But today I wanted to get a little more in depth about contactors. Of course, contactors, you're going to have some that are single pole, like this, single pole like that. Other ones are going to be double pole like this. So now you're going to have what they call L1, you're going to have L2, and then this is going to be T1, and this is going to be T2. So this is the terminal, that's what's going out to the load. L1 and L2, that's where power is coming in. That's power supply. Sometimes you're going to end up with what they call L3. And this, of course, would be T3 right there. So you're looking at 3 connections right there. So you're going to have T1, T2, and T3 because this is going to be for what they call a 3-phase system. 3-phase. In other words, you have 3 hot legs coming in. If you only have 2, that's going to be called a single phase contactor. And we'll talk more about phases and how all that works later on in another video. But right now, I wanted to mention that yes, we have these 3 right here, L1, L2, and L3. That's your power supply. Now, what can you hook up this contactor to? Of course, we can hook this up to a motor. So now we have a motor like this, and this motor could actually have, let's say, 3 connections going to it. So you're going to have T1, T2, and then T3 like this. So we can hook these up to that. It's going to cut that motor on and off. If you notice, there's no neutral. We'll get to that when we talk about motors in another video. But this is what they call a 3-phase motor. Now, that's good and that's great. That's how you hook it up. But the question is this motor. How big is this motor? Will this contactor be able to handle what that motor is going to do? Now, what I want to show you is on the side of the contactor, there's a little sticker on there. It's got all this writing and all these numbers and stuff on it. But for what we do, we need to know what that is. We need to know what all those numbers are. So let's take a look at this first sticker that it's on the contactor. When we look at this one, we see that the contactor is made by White Rogers. That's the manufacturer. Okay. Then below that, we see that it says 24-volt coil, and it's 50, 60 hertz. So first of all, the coil. Coil is 24 volts. Very, very important because if you hook it up to 110 or you hook it up to 240 volts, you're going to burn it up. So be careful. Make sure you only hook it up to this one. You only hook up to 24 volts. Now it says 50, 60 hertz. That's the frequency that the electricity is, let's say, traveling at or working with. We'll get to that. I'll explain all of that another day. But for right now, here in the United States, we typically use 60 hertz. 60 hertz here in the United States. Other countries, yeah, they use 50 hertz. So this one you can use here and or in other countries. Then we see that it's got the contactor model number on there. And then it says contact rating per pole. Per pole. So we see that, first of all, it says VAC. VAC means voltage, alternating current. Volts, alternating current. So this one can handle, or this one's rated for these 3, for 277 volts, 480 volts, and 600 volts. So this contactor, we can use it on these different voltages without a problem. And the manufacturer is telling us that those are the amperages to the right that we can use it on. Now, before we get into that, let me just explain that there are 2 different types of loads. When you're dealing with what we do, you're dealing with basically 2 different types of load. One of them is going to be an inductive load, the other one a resistive load. Without getting too much into it right now, let me just say that an inductive load. An inductive load is one that generates a magnetic field. So for example, a motor. A motor It rotates and it generates a magnetic field, so that's an inductive load. The coil in a contactor generates a magnetic field, so now that is an inductive load. So anytime it generates a magnetic field is what they call an inductive load. So what is a resistive load? A resistive load is one that does not generate a magnetic field. I don't like complicating things, so an inductive induces a magnetic field. A resistive does not generate a magnetic field. So now, when we look at this, we see that it says FLA. FLA, it has 30, 30, 30. So that at 277 volts, 480 or 600 volts, this can handle 30 amps. So in other words, this is what they call a 30 amp contactor. This is going to be a 30 amp contactor. Now, FLA, that is your full load amps. Full load amps, the way I like to explain this in the classroom is the maximum a motor or a component can draw without overheating. So full load amps is the maximum you can draw, maximum amperage, without overheating that component. Now, the next one says LRA. LRA is locked rotor amps. Locked rotor amps is basically saying that the rotor on that motor, it has stopped and is locked and is not rotating. Because of that, the amperage is going to go up. We'll talk about why on a different video, but yes, the amperage is going to go up. So the maximum this can draw, let's say, if we look at this, at 277 is 150 amps. This can handle at 480 volts, 125 amps, and at 600 volts, it can only handle 100 amps. And if you notice, as the voltage goes up, the amperage decreases because now you have more voltage, more pressure pushing the amperage through. So now the amperage that this can handle is going to drop. It's going to drop. So we need to keep that in mind. So we're going to have to look at the motor and see what the locked rotor amps are and see if this contactor can handle it. Now, the last one was the resistive, RES. That's the resistive load. Like we said, that's not generating a magnetic field. What kind of loads do you deal with that do not generate a magnetic field? Well, first one that comes to mind is a heater, a duct heater, or a heater on a furnace. All they do is they generate heat. They don't generate a magnetic field. So now, on resistive loads, if we look at this little sticker, it says that it can handle 40 amps all the way down, whether it's 277, 480, or 600 volts. So now we see that what amperages you can use this for in a duct heater, for example, a three-phase duct heater. So this can be used on that, but it cannot draw more than 40 amps. If it draws more than 40 amps, you need to go to the next higher contactor. So now let's take a look at a different sticker here. So now we see on this one here, again, it says that it's single phase. Single phase, the coil is going to be 24 volts. Below that, we see that it says VAC. Again, just like the other one, 240, 277. Below that, 480. Below that, 600. To the right of that, it says FLA. Again, full load amps, 30, 30, 30. So again, this is a 30 amp contactor. But if you notice, the locked rotor amps on this one is a little bit different than the other one. They're saying on this one, 240, 277, it can handle 180 amps, locked rotor amps. 480, 150, the other one was 125. 600, 120, the other one was 100. The resistive is the same thing. Resistive is 40 amps straight down. When you look at a contactor, look at the tag and see what it says. Like this one here, like the ones we looked at, those are 30 amp contactors. Single phase, which means you might have only one or two contacts here, or three phase, which means that you have all three hot legs like this. Now, hopefully this makes sense on the stickers, and hopefully this helped. Again, my name is Julio, Aircon Academy, and thank you very much. Make sure you go to YouTube, follow me on YouTube, and like the video on here, and I'll see you soon. Thank you.